Let's review some of the pitfalls and caveats when constructing a control structure in a loop. We'll mention a few common errors and also things that we should take notice. You may already know that in Java, you can initialize multiple integers in a single line, which is a concise way of assigning initial values to several variables of the same type. For example, you can write integer x equals 1, comma, y equals 2, comma, z equals 3, semicolon. Same thing with respect to your initialization for your for loop. You can concatenate using a comma delimited single line fashion as illustrated above by initializing multiple counters. This is very useful when you have a for loop, for example, for doing divide and conquer search algorithms or solving any problems in a loop where you will have two pointers, I and j. A lot of times you will use something like this to initiate two different iterations, or you could have simply a iteration that converges towards the middle using I and j, so on and so forth. Same thing with your action, which is the increment in this example, by concatenating or having both of these separated by a comma. Notice that you can do this only if these counters are of the same type. In the context of a for loop, your counter is always an integer. Do not use float or double. You're going to get an error. And notice the use of semicolon to separate these. Let's move on to the next one. Another caveat is the interoperability of a for loop and while loop. Notice that you can write while true. This is simply an infinite loop. To avoid having an infinite loop, which will eventually exhaust your available memory space and causing your application to crash, you will have some sort of break that exits or stop this entire while loop. You can write something similar with a for loop by simply just leaving these segments, initialization, condition, and the actioned portion of your for loop empty. Doing this is not recommended. However, not without having some sort of provision in do something or one of these statements for conditionally breaking your for loop out of infinite iterations. This is pretty confusing from a syntactical standpoint. So sometimes it is preferred if you were to have something like this on the left, you might as well just use while loop with true. Still, you have to be super careful and judicious about the use of true because this is the ground for lots of infinite loops and code crashes when your infinite loop does not terminate. Let's move on to the next one. Another common error is when developers make mistakes by adding a semicolon. Notice that the entire for loop should not be terminated with a semicolon or statement. If you have this, this is a logical error. This logical error is part of the compilation error. You should not be able to compile even with this syntax in place. Let's look at another. Same thing with while loops, where people could be inserting semicolon by mistake at the end of the conditions. This creates, again, another compilation error, so your code will not be able to compile. But notice from our do while lecture that you do need a semicolon to terminate your do while loop. This is the only place of all of the control statements you have today where a semicolon is required. So please remember that. If you do not have the semicolon, you're going to get into some sort of logical error, and your compiler will let you know. Let's look at all of the control loops we have today and decide when it's best to use either. So far, we've looked at 3 loops, while, do while, and for. You can basically elect to have any one of these loops to proceed with. Just remember these loops, they are differed mostly on the syntax standpoint. In terms of their functionality, they are interchangeable. So interoperability is there. Sometimes it's easier just to write everything inside a while, and you have this very succinct conditional check versus having this for loop that requires you to write 3 segments. Now, speaking of do while, this is a complete different construct feature-wise than while and for loop, because do while does require the enclosed statement to be evaluated first, once prior to entering the loop, whereas while loop and for loops both require the statement to be evaluated only if the conditions is true. Knowing that, you can change while into a for. You can also undo your while and make it into a for loop. Let's look at some of the recommendations. There's no right or wrong answers in terms of which loop to use. choose what's right for you. And a lot of times people prefer to use while loop all the time versus for loop and vice versa. Using a for loop allows you to explicitly count the number of times by specifying that conditional and with a counter that is pretty explicit. While loop doesn't really have that, so you kind of have to build your counter inside the while loop. Basically, you have to keep track of your counters in a while loop. That's a separate mechanism you have to enable. Otherwise, you get into this infinite loop. From a performance standpoint, there's really not much difference between these three types of loops. They're all equally efficient. One final thing about these loops, you can write nested loops. In other words, you can have a for loop inside another for loop, which is inside another for loop, or you can choose any of these loops to be a juxtaposition of different types of loops, meaning you can mix while loop with for loop, or you can have a whole bunch of while loops inside a while loop, you can have for loops. Just be careful of having these nested loops because a lot of times you can, again, get into a very long computation taking you forever to achieve what you need if you don't have the proper break to get out of these loops. And remember, these breaks, if any, only break you out of the closest loop. In other words, one break will break out of the innermost one, but not the outermost, which is the for loop. These are considerations you have to have prior to getting yourself into nested loops. There's a lot of problems out there that will require you to write nested loops. Multiplication, for example, could be a 3 nested loops, and certain computation will require double nested loops. Applications vary depending on the problems you're trying to solve. This should complete our discussions on the pros and cons of these loops and some of these caveats and pitfalls associated with them.